Hello and welcome to this video from Excel Dev Studio. This is video number 2 of 6 from Introduction to Building Microsoft Excel Solutions with VSTO. VSTO stands for Visual Studio Tools for Office. With VSTO, we can build solutions to extend what Excel can already do. If you haven't done so already, please check out video number 1, which gives a background on VSTO and compares it to other Excel development tools. This video in particular covers section 2, setting up your environment so you can have everything you need to develop your Excel solution. This video also covers section 3, the 2 different types of Excel solutions we can build. With VSTO, we can either build an add-in or a document level solution. We will cover the differences between them and how to create one along with simple examples. Also, as discussed in video 1, we can build VSTO solutions with either VB.NET or C#. But in this course, we will only use C#. In this section, we cover setting up your environment. To develop Excel solutions, you will need Visual Studio, the VSTO APIs, and Excel 2013 or higher. In this course, I am using Excel from Microsoft 365, which is the latest version of Office as of the date of this video, July 2023. We will be downloading the latest version of Visual Studio as of this date, which is 2022. If you already have Visual Studio installed, then we just need to check for the necessary packages. To check, we need to open up Visual Studio Installer to see what's already installed. Visual Studio Installer should have been installed from when Visual Studio was originally downloaded. Here, I have Visual Studio Installer open. I have both Visual Studio 2019 and 2022 installed on my PC. For this video, we want to work with Visual Studio 2022. We hit the Modify button. Now, from this screen in the Workloads tab, we want to look for .NET Desktop Development Package and see if it's selected. This package will give us C# and will also give us the .NET Framework. Secondly, we also want to check if Office SharePoint Development is selected. This package will give us the VSTO APIs that we need to develop Excel solutions. If you need to install either, then select them and press the Install button at the bottom right. If you need to install Visual Studio, let's go and download it. Okay, now we're just going to go to our browser and search download Visual Studio 2022. We follow the link, and what we want to look for is the download link for the Community Edition. The Community Edition is the one that is free. So now we just hit download on this. And now we see on the right side of our screen that it's currently downloading. And now we're just going to go and say show all downloads. As we see, we just run this Visual Studio setup. Now it's unpacking. And then next over here, we need to agree to Microsoft terms. And we say continue, and this will actually begin the install process. At some point during the install process, you will come to this screen. As mentioned before, we want to select the packages we need to develop Excel solutions. Make sure to select .NET Desktop Development and also select Office SharePoint Development. This will give us the necessary APIs we need. After this point forward, continue to follow the instructions until Visual Studio is completely installed. And there you have it. Now, you should have Visual Studio installed, and we can begin creating Excel solutions in the next section. In this section, we're going to discuss creating Excel solutions. When we automate Excel, we either create a document-level customization solution or an add-in solution. Here, we will describe the differences between them and how to create them by going through examples. So now the question is, how do we decide which one to use? Well, to decide which type is best, think about whether you want your code to run only when a specific document is open, or whether you want the code to be available whenever the Excel application is running. When you automate Excel with document level customization solutions, these features will only be available when the file is open. They are specific to this document. In other words, if your file is open and it's a current active file, then the automation features will be available. Otherwise, they're not. On the other hand, a VSTO Excel add-in consists of an Office solution that extends the functionality of Excel and is available to all workbooks. This means that regardless of which file is open, these automation features will be available. Because of the differences between document level customizations and VSTO add-ins, their code base is stored differently. By code base, I mean their assembly. An assembly is partially compiled .NET code. For document level solutions, the assembly is stored as part of the document. So when the document or file is open, the assembly will load. When the file is closed, the assembly will be unloaded. For VSTO add-ins, the assembly is stored separately from any file and will be loaded when the Excel application is opened. Thus, the assembly will be unloaded when the Excel application is closed. Let's create a new document level customization Excel solution. If you have started from the main Visual Studio screen, select Create a New Project on the right side. We get to the screen where we can search for projects. For a document level solution, we want to look for Excel VSTO Workbook. I already have a shortcut for them on the left side, but we can search for it in the search box. We can also filter to narrow things down. After we select the project, we select Next. Now in this screen, we choose the project name, location, solution name, and which .NET framework we want to use. I will name the solution to Excel Workbook Demo 1 and will leave the full values for the rest. We now have the option to name the actual Excel file and to also select the file type. The default file type is XLSX, but we could also choose macro enable, binary, or 2003 format. I will leave the default values and hit OK to create the project. Now we have our documentation level Excel solution, and we will go into more detail in the next video. Here, let's take a look at a document level customization solution. First, let me bring your attention to the Solution Explorer. Starting from the top, we have the solution. The solution is what holds our project. This is our project, which is of type VSTO workbook. Below is our actual Excel file. It is just like any other Excel file, except that behind the scenes, there is code to automate it. Now, let's look at the class Sheet 1. It is a class that represents the worksheet Sheet 1. Expanding it, we see that there's code behind it. This code is handled by Visual Studio and we shouldn't touch it. If we click on the class Sheet 1, we now see Excel with Sheet 1 open. This is like having the regular Excel application open with some limitations. For example, we can apply formatting or even bring up the context menu. We can even add new worksheets to the workbook. After adding a new sheet, we see that there is now a new class for the worksheet in the Solution Explorer. Now, not everything is available. For example, you can't access the File menu, but overall, the vast majority of features are available to us. When working with document level customization Excel solution, it is best to have the Excel application open in the background. Otherwise, we might not see Excel properly from Visual Studio. For example, my Excel application is closed in the background, And let's see what happens when I try to open sheet 1 in Visual Studio. As we can see, columns and rows are missing. We can't see the worksheet tab either. To fix this issue, we need to have the Excel application open in the background. Let me open my Excel application and try again. Now we can see that sheet 1 is fully visible. So make sure to have the Excel application open in the background to avoid any glitches. If you're having trouble viewing Excel in Visual Studio, where you see a blue screen such as this, then you will probably get these two messages over the top. One reads, change Microsoft Excel display settings, and the other says, change Visual Studio 2022 display settings. These messages are here to help us resolve this display issue. When we click on the change Microsoft Excel display settings, it gives instructions to go under the Excel application, under Options, General, and select Optimize for Compatibility. Now let's open the Excel application and make this change. Here I have my Excel application, and I will go under Options, General, and select Optimize for Compatibility, and then click OK. Now, let's go back to Visual Studio and address the second message. When we click the Change Visual Studio 2022 display setting message, it says to go under Tools, Options, General, and uncheck Optimize Rendering for screens with different pixel density. Let's go ahead and make this change. After we make this change, we will need to close out our project and restart Visual Studio for this change to take effect. Let's open Visual Studio again and try and open sheet 1. Make sure that your Excel application is already open in the background. And now we can see sheet 1 is displaying correctly. In conclusion, if you're having display issues, be on the lookout for messages on how to address them. When adding code to a documentation Excel solution, we have the option of either putting the code behind a worksheet or code that applies to the workbook itself. The code behind a worksheet will be specific to that worksheet and will execute only when activity or events occur that pertain to that worksheet. For example, code can execute when the worksheet is changed or when it's recalculated. If we have a workbook that has 5 left-hand worksheets, then we could put code behind each one. On the other hand, adding code to the workbook itself is broader and it pertains to properties and events for the overall workbook. For example, code can execute whenever a new worksheet is added or when the workbook is saved. Code that applies to the workbook will go into the active call that is workbook. In the following videos, we cover a few intro examples of how to add code to a documentation Excel solution. We won't go into too much detail as we save that for another section, but they will give us enough to understand the basic concepts. Let's have a closer look at the objects in our document level customization solution. Here we have sheet 1, and we can see the code behind it by right-clicking. By default, Visual Studio added 2 methods, startup and shutdown events specific to sheet 1. The code inside the startup method will be called whenever the workbook is open. Conversely, the code inside the shutdown method will be called whenever the workbook is closing. Right now, we are inside object sheet 1. Therefore, we can use the disk pointer to access the properties and methods of sheet 1. For example, we see its name property and its activate method. We also have access to the properties and event handlers for sheet 1 in the properties window by double-clicking sheet 1 in the Solution Explorer. And not all the properties are available here, but all the event handlers are. We can see the event handlers for startup and shutdown events. As a simple example, let's set a cell in sheet 1 with the current time and startup. Our code will go inside the startup method. Let me open sheet 1. First, we label and add orders to cell E5. We will put the current time in cell F5. We format cell F5 with the time mask. Let me switch to code view. We will use the this pointer and select range property F5 and then assign the current time using the datetime static object. With this code, every time the workbook is open, it will set cell F5 with the current time. Now, let's run the project. As we can see, cell F5 has the current time, and this will happen every time the workbook is open. Now, let's review the ThisWorkbook object. Adding code to the ThisWorkbook object is broader as it represents the workbook itself. The ThisWorkbook object has its own properties, methods, and events. We can see some of its properties and events in the properties window. Similarly to sheet 1 by default, it already has handlers for its startup and shutdown events. Let's do the same example we just did with sheet 1, where we put the current time in F5, but instead with the ThisWorkbook object. We first copied the example from sheet 1 and also commented out so it won't execute again. We need to modify the code slightly for it to execute properly. To access the cell for sheet 1 from the ThisWorkbook object, we first need to reference a worksheet object that points to sheet 1. We can do this one of two ways. The first method is to use the this pointer for the ThisWorkbook object to get its worksheet collection. From the worksheet collection, we can get a reference to sheet 1. Whenever we create a worksheet, we first need to cast it to a worksheet. This is because a worksheet pertaining to a workbook can also be a chart. After getting a reference to sheet 1, we just replace this with our SHT variable. The second method is by using the global static object, which is created with every document level customization solution. With the global object, we can reference any worksheet. In our example, we only have one sheet, but if we have 5, we can reference all 5. With the global objects, we can also reference the ThisWorkbook. For example, if we were in the sheet 1 class, we can also access the ThisWorkbook object. Going back to our example, we comment this out and we create the SAC variable using the globals object. One thing to note is that there is no need for casting using the globals object. Now let's run the project. As we can see, we are able to set the value for F5 directly from sheet 1 or from the ThisWorkbook object. In the previous examples, we set cell F5 with the current time by putting code in the startup method in sheet 1 or in the ThisWorkbook object. For this example, we are again going to set cell F5 with the current time, but instead by using a button. Every time the button is pressed, it will set F5 with the current time. With Excel document level customization solutions, we have the option of using WinForm controls. If we expand the tool task pane, we can see the available controls. We see the color box, list box, and bind controls. For our example, we want to use a bind control. We just drag it to our worksheet. We can resize it and move it as we need. Just like any other WinForm controls, we can set as properties and events using the Properties window. Now, let's add the code to set F5 at the current time. We copy the code from the ThisWorkbook startup method and also comment it out. We double-click the button to access its handler. We paste the code and then run the project. If we press the button, we can see F5 is updated with the current time. We just showed how to create a new document level solution and went over a basic example. Now, let's cover creating add-in solutions. Before the result, let's do an overview. The automations created with a VSTO add-in will be available to all open workbooks. This is because add-ins are an application-level solution, whereas document-level customization solutions are specific to a workbook. The top three use cases for creating an add-in would be 1. Adding a ribbon with functionality. For example, the ribbon can offer functionality to add a new worksheet template to the active workbook. The second use case is adding a task pane, where it could have custom functionality such as downloading reports. The third use case is trapping events. For example, we can execute code whenever a new workbook is added or after any workbook is saved. Let's create a new VSTO add-in Excel solution. If you're starting from the main Visual Studio screen, select Create a New Project on the right side. We get to the screen where we can search for projects. We want to look for Excel VSTO add-in. I already have a shortcut for it on the left side, so I would just double-click. Here in the configuration screen, I will update the name to Excel Add-in Demo 1. Leaving the default values for location, solution name, and a dynamic framework version, and we'll press Create. Now we have our Excel VSTO add-in solution. Let's review the Solution Explorer. This is our Visual Studio solution. Here is our Excel VSTO add-in project. This is our add-in class, and it represents the Excel application. It has a startup method where we put code we want to execute when the add-in starts, and a shutdown method for running code when the add-in is shutting down. Normally, when creating Excel add-in solutions, we add a ribbon to the project. For this video, we are not going to go into the details of creating and customizing a ribbon. We cover ribbons in another video. As a basic example, in this video, we will demonstrate creating an event to handle adding a new tab sheet. The event will present a hello message with the new sheet name whenever a new sheet is added to a workbook. To get to the new sheet event, we use the disk pointer and look for the workbook new sheet event. Once we find it, we enter plus equals and hit tab, and Visual Studio will create a new handler for us. The handler has a workbook and object input parameter. The workbook parameter represents the workbook where the new sheet is being added, and if we want, we can use any of its properties and methods within our handler. The second parameter is the new worksheet that was just added. We can also call any of its properties and methods, but we must first cast it to a worksheet before doing so. To create the hello message, we first cast the worksheet object into a new variable called new SHT. Now we create a message that will say, create a new sheet, and will display the new sheet name. For convenience, we use the string format helper method. Once we are done with our code, we run the project. To test the handler, we just need to add a new sheet to the active workbook. Let's add a new sheet. We see the message. Let's create one more. As we can see, every time we add a new sheet, we get the message from the handler. Thank you for watching this video. If you enjoyed it, please give it a thumbs up and subscribe to our channel. Please check out video number 3 that discusses the Excel object model.